Good afternoon, ladies and gentlemen. Welcome to the technical forum here at the group exhibit Hydrogen Fuel Cells and Batteries. And this year in the Hanover Fair 2015, I invite you all to have a seat, have some complimentary drinks by the house. There's a lovely lady walking around to serve you with the drinks. Also, I'd like to invite you for every presentation, every 15 minutes, we'll have a new presentation concerning the hydrogen industry. The next topic will be hydrogen generation on demand for fuel cells and internal combustion engine. And my next speaker, the CEO of Adventure, JSC, will be explaining why there's no hydrogen storage required. So please welcome with me on stage Dr. Dara Grigorova.
Good afternoon. I think it's loud. Must I shout more? Or it's okay? Okay. The topic is fueling, with hydrogen from alternative fuels. Last year, on the cover copy of Green Fleet Journal was a big title said, "Is hydrogen happening? Will hydrogen be the available alternative fuel in 2012? The answer is, as we all know, yes. But we know that there are. Why is coming back? Motor cars driven by hydrogen. Those are BMW series with hydrogen in internal combustion engine. Those are the many types of fuel cell driven vehicles with a hydrogen. The real question is, however, where can I refuel? Is there fuel station for hydrogen? Adventure, which is our company, a Bulgarian-based company, has developed a proprietary technology for generating hydrogen from fossil fuels, alcohols, natural gas, hydrogen on demand without storage required. Advantages of the technology is over the existing processes that really hydrogen is generated when you need it. You don't need to store it. And that removes actually the obstacle of lack of infrastructure, which is in the moment for hydrogen supply, and also eliminates the issues of safety and hydrogen storage, because hydrogen storage under high pressure is not something that is exactly safe approach. The advantages of our system technology is that it's a multi-fuel technology. It fuels, hydrogen can be generated from methanol, ethanol, natural gas, gasoline, or diesel. From all those 5 types of fuels, we can generate hydrogen, and like I said, on demand. The next one. The efficiency of the technology is high, and it is based actually on the proprietary catalyst which we manufacture in our ISO certified facilities. As you can see in those slides here, we're talking about diesel reforming. We're talking about efficiency or recovery of the hydrogen even over the theoretical value. Why? Because the process which we're using is oxy-steam reforming process. So we're generating from the steam between 6 to 8% additional hydrogen from what we are getting from the fuel which we are adding. Another advantage of the technology is that it's working at relatively lower temperature than the conventional one. Diesel and gasoline, we are reforming at temperature between 600 and 650 maximum. Natural gas reforming process is between 700, 725. Methanol and ethanol starting from 280 to 320, 350. So it is a very high, low temperature systems and the catalysts which we are using. The company has two patented designs for hydrogen generating reformers. One is a system for fueling internal combustion engine with hydrogen-rich reformate. The other is a system for generating hydrogen and purifying this hydrogen for fueling fuel cells. This is actually the PFD of the system for fueling fuel cells. The system consists of two units. We do have a reformer with incorporated heat exchanger, and after that we do have a purifier of the hydrogen produced and fueling the stacks. The efficiency of the reformer is greater than 90%. The carbon monoxide, which is coming from such a system, is in the region 2 to 3%. The purification stage is bringing down the carbon monoxide to less than 10 ppm, which is the required. One specific advantage is that the temperature of the purification is in the region of 110, 120 Celsius, which is additional advantage because at such a temperature and with our catalyst, we have a very little loss of the hydrogen during the purification stage. Like I mentioned before, the temperature of the reformer vary from 280 to 700 depending of the feed which you're using to generate the hydrogen. Integrated elements we have in the system for vaporizing and preheating the reagent before they enter the reforming system. Integrated heat exchanger where the water is condensed and recycled again in the system. Again, I'm repeating that the purifier had this very good characteristic that is really highly selective. The catalyst which we're using for purification of the hydrogen fuel had a very low affinity towards the hydrogen. And because the temperature of the purification is very low, we have less than 1% loss of the hydrogen, which I think is quite important for this purpose. Here we do have some information and our reformers for methanol. Given for, we have reformers for methanols for 2.5 or from 2 kilowatts up to 10 kilowatts, giving you the product that is required, the fuel consumption, the size. The size is very compact actually. We're talking between 500 length to 700 millimeters length. We're talking of system that weight from 20 kilograms, which is the smaller one, going up to 40 kilograms, which is the larger one for the 10 kilowatt. What is very important that the system is actually largely independent of external power. Why? Because the process which we're using is oxy-steam reforming. So we're generating some heat during the process because it's partly oxidation process. Cost of, this is actually for natural gas, the cost per kilowatt for with this system is given here 16 cents, but 16 cents is base and the cost of natural gas, which is in Bulgaria, which is much higher what in Germany people are getting. So the cost here is of 470 euro per cubic, when in Germany is much lower, 370, I believe. which means that the cost actually per kilowatt is going to come down to in the region of 12 or 13 cents. Gasoline reformer, again, we have a bigger system, which is to reform the gasoline up to, if it's necessary, 20 kilowatts. The sizes and the dimensions are more or less the same. Of course, slightly higher when we're talking of the 20 kilowatt fuel cell here. The next system which we have is a system for generating hydrogen for fueling internal combustion engine. The objective behind this was two sides. We do have economic benefits and we have environmental advantages. The system, again, the PFD of the system, we have water, we have fuel, we have air. The system can be with diesel, gasoline, natural gas, or ethanol accordingly. We have the reformer with incorporated heat exchanger, like I mentioned before, but after the heat exchange, after the reformer, we have additional heat exchanger, which is bringing the temperature of the reformer down to 40 centigrades, because the temperature of the gases that are coming out are in the region of 100, 110. We are using, actually, to drop the temperature to 40 to allow us to fuel directly into the air intake of the engine, the reformer that is coming. This is not completely clear like for the fuel cell. We don't purify here from carbon monoxide. It is slightly variation in the technology, but it's sufficient to go directly in the internal combustion engine. We have been using this system to run a Nissan 1.2 liter engine for 2 years now, without any alteration of the engine or without any problems the engine to give us. Okay, like I say, the temperature of the reforming is from 550 and 650, depending what is. And like I mentioned, we are bringing the temperature before to go to the engine to 40 degrees. The water vapor is condensed and recycle again. So we don't have a big water tank for the steam reforming process. The system actually starts to work in less than 2 minutes, because in this particular case, what we do have is we are putting the fuel directly through the reformer. At the beginning, the engine is working with evaporated fuel. But somewhere around the 7th or 8th minutes, you start to get the advantages of the reforming process, because we are starting to run the engine with a hydrogen-rich reformate. So by the 15 minutes, we have up to 20% fuel efficiency, reducing the hydrogen consumption, the fuel consumption by 20%. Okay, for diesel, it's the same story. It's just advantages that you can run simultaneous with diesel with the hydrogen-rich reformate. The next one, please. What is the gasoline reformer? Like I say, we are giving here what is the consumption. We're measuring it with the revolutions per minute. With 2 liters of gasoline, we are reaching over 300 revolutions, 2.5, 360. Like I said, it is actually independent from external energy because it's generating itself. Okay, the next one, please. Those are the advantages for the environmental. Those are results when the engine is running with conventional gasoline. Those are results when it's running with the reformate. This is a data without a catalyst for purification at the end of the exhaust. You can see specifically the nitrogen oxide, they're virtually not existing. There is no particulate matter. Everything, the carbon dioxide is reduced by over 20%. So really, the advantages are very great for this. The next one, please. This is the fuel consumption This is with diesel. This is with the reformate. You can see it is 20%. Saving with such a system is quite significant because you don't need the expensive catalyst which you're putting on the end. I don't have a time for the next one, but because the technology, our technology is hydrogen generation, we have a third system which is for purification of nitrogen oxide using the hydrogen generated from the diesel that you are running the engine to purify the nitrogen oxide more than 80 up to 95% just using part of the diesel that is running to your engine to reform that diesel to generate hydrogen, which actually is converting the nitrogen oxide to the levels of 20, 30 ppm, which is quite significant things. Okay? This is the DPF, but we don't have time, I believe. So the next one, yeah. Those are the savings, like I say. You can see, depending on the fuel that you're adding, you have 80% or 85%. When you add a little bit more of the fuel, you're going over the 90% conversion of the nitrogen oxide. And the last one is, this is our company, part pictures taken from the facilities, the production facilities. We have a highly sophisticated laboratory for research and development. And like I mentioned at the beginning, we are ISO certified production site. Thank you very much. And thank you for giving me the extra time.
Thank you, Dr. Dara Grigorova. I think a very interesting topic. I'm sure there will be questions. We have to take the questions to your booth.
Yes.
Yes.
62, D62, please, you're welcome. We have actually there some of the prototypes of those systems that you can see.
Thank you very much. Upcoming talk in only 2 minutes' time will be fuel-flexible reformers for stack integrated systems in hydrogen and syngas generation from Precision Combustion, Inc.